Our solar system is an awe-inspiring place. It's a cosmic ballet of planets, moons, asteroids, and comets, all orbiting around a single star, our very own sun. This celestial dance has been going on for billions of years. It's a story of gravity, light, and the constant interplay of cosmic forces. Imagine a vast, dark canvas sprinkled with countless stars. In one corner of this grand cosmic tapestry lies our solar system. It's a relatively small neighborhood in the grand scheme of the universe. But within its boundaries lies a treasure trove of celestial wonders. Our journey begins at the center, where the sun, a giant ball of burning gas, reigns supreme. Its immense gravity holds the entire solar system together. It bathes our planet in light and warmth, making life on Earth possible. From the scorching heat of Mercury to the icy depths of Neptune, each planet in our solar system has its own unique story to tell. These stories are written in the language of craters, volcanoes, and swirling storms. They speak of ancient collisions, volcanic eruptions, and the relentless forces of erosion. By studying our solar system, we gain a deeper understanding of our place in the universe. We begin to appreciate the delicate balance of conditions that allowed life to flourish on our planet. First stop, Mercury, the smallest planet, is a rocky world, zipping around the sun. Venus, shrouded in thick clouds, is the hottest planet, a cautionary tale of the greenhouse effect. Earth, our home, is a vibrant oasis teeming with life. It's the only known world with liquid water on its surface. Moving outward, we encounter Mars, the red planet. It's a cold, dusty world with a thin atmosphere, but it holds the promise of ancient life. Jupiter, a gas giant, is the largest planet in our solar system. It's a swirling vortex of storms, with a giant red spot that's been raging for centuries. Saturn, known for its magnificent rings, is another gas giant. Its rings are made up of countless ice and rock particles, each orbiting the planet like tiny moons. Uranus, an ice giant, spins on its side, tilted at an unusual angle. Neptune, the farthest planet from the sun, is a dark, cold world, whipped by supersonic winds. The sun, a yellow dwarf star, is the heart of our solar system. It's a giant ball of hot gas, mostly hydrogen and helium. Deep within its core, a process called nuclear fusion is taking place. Hydrogen atoms are fusing together to form helium, releasing an enormous amount of energy in the process. This energy radiates out from the sun in the form of light and heat. It's this energy that warms our planet and drives our weather patterns. It's the reason why plants can photosynthesize and produce the oxygen we breathe. The sun's gravity is also what keeps our planet in orbit. Without the sun, there would be no life on Earth. Our planet would be a frozen, lifeless rock. The sun is not only the center of our solar system, but it's also the center of our existence.
At the very edge of what human eyes and human instruments can perceive, there exists a galaxy. It glows red. Not the red of fire or warning, but the deep, stretched crimson of something impossibly far away. The observation of MOMZ-14 provides scientists with a valuable opportunity to investigate the initial phases of galaxy formation, rates of star formation, and the processes of chemical enrichment in the early universe. Light so ancient it has been pulled thin by the expansion of space itself. MOMZ-14 is currently recognized as the most distant galaxy ever observed, exhibiting a redshift of Z equals 14.44. This galaxy is being observed as it existed merely 280 million years following the Big Bang. The discovery and spectroscopic confirmation of MOMZ-14 were conducted by NASA's James Webb Space Telescope, JWST, establishing it as the farthest and earliest galaxy reliably detected as of January 2026, NASA, ESA, CSA, STSCI. The light from this galaxy has traversed over 13 billion years to reach us, enabling astronomers to study the universe during a time when it was less than 2% of its current age. The identification of the galaxy was achieved using JWST's Near-Infrared Spectrograph, NIR spec, which accurately measured its redshift, thereby confirming its extreme distance. Despite its relatively small size, MOMZ14 exhibits unexpected brightness and a chemical enrichment characterized by unusual amounts of nitrogen. It appears to be actively clearing the dense hydrogen fog that permeated the early universe, offering significant insights into the cosmic dawn, a period marked by the formation of the first galaxies. The discovery of MOMZ14 challenges existing theoretical frameworks regarding the rapidity with which galaxies can form and evolve shortly after the Big Bang. Each distant galaxy serves as a cosmic time capsule, offering insights into conditions present during the infancy of the universe and contributing to answers regarding fundamental questions about cosmic evolution. This discovery also underscores the exceptional capabilities of the James Webb Space Telescope, JWST, in identifying faint, early universe galaxies that were previously undetectable by instruments such as the Hubble Space Telescope or Spitzer Space Telescope. MOMZ14 signifies the current boundary of our observational capabilities, offering a distinctive insight into the universe's initial few hundred million years. This discovery is poised to transform our understanding of the processes underlying early galaxy formation and evolution. Most scientists look at that galaxy and see a boundary, a wall, the end of the knowable. Dr. Michael E. Blackwell looks at it and sees home. Dr. Blackwell is not a conventional man. He holds a PhD in physics, but he wears the title he has given himself with equal pride: engineering quantum physicist. The title tells you something important about how his mind works. He does not merely theorize, he builds. His focus is practical theory married to ruthless craftsmanship. For years, Dr. Blackwell has worked in relative obscurity, a cluttered laboratory filled with equations scrawled on every surface, models of atomic structures suspended from the ceiling like strange constellations, and a soldered collection of instruments that hum with irregular life. There is always, a window facing the night sky, and through that window, the red smear waits like a promise. Those who know him well describe him as single-minded, not cruel, not unkind, but prioritized. He arranges problems like modular parts, isolating variables until a path forward reveals itself. That precision is why the sight of a distant red galaxy does not intimidate him. It invites him to begin rearranging the universe's puzzle pieces, and he believes the configurator will let him do exactly that. The invention that sits at the center of his laboratory, and at the center of his plan, has no formal name in any scientific journal. Dr. Blackwell calls it simply the configurator. It does what no technology before it has done. It breaks matter down to its atomic constituents and reconfigures those atoms in any arrangement its operator chooses. Not molecules, not compounds, atoms. The fundamental building blocks of everything that exists. In practice, this means that Dr. Blackwell can take any material and reduce it to a luminous cloud of individual atoms, suspended in a carefully controlled quantum field. The process is surgical and brutal in the same breath. Atoms are unraveled from bonds, held in quantum suspension, then guided into new architectures. And then, with the precision of a master architect working at the smallest possible scale, he can reassemble those atoms into any structure he desires. A new alloy that resists microfracture under extremes. A fuel source of almost incomprehensible energy density, engineered to release or store energy on demand. Or a spacecraft, grown rather than manufactured. Colleagues have called his ambitions eccentric. Some have called them impossible. Others have raised ethical questions. Who should have power to rewrite matter? Dr. Blackwell answers with demonstration, not debate. For him, the configurator is less a weapon than a microscope turned outward, a means to design materials and systems that nature never evolved to produce. It is precise, unforgiving, and singularly capable of making his voyage conceivable. The galaxy Dr. Blackwell has chosen sits near the cosmological horizon, the boundary beyond which the expansion of the universe carries objects away from us faster than light itself can bridge the gap. Here is the paradox that defines his challenge. The faster a ship accelerates toward that galaxy, the faster the galaxy appears to recede. Push harder, and the target seems to slip further into the red. It is an inversion of intuition. On Earth, we close distances by accelerating. Here, acceleration feeds the distance. Classical measures declare the target unapproachable because expansion is a property of space itself, not motion through space. Light from that galaxy is stretched to extremes, redshifted until its features become faint and ghost-like. Because at the heart of his life's work lies a question that has haunted him since his doctoral years. What does it mean to go somewhere that the universe itself seems determined to keep you from reaching? The question is not merely mathematical for Dr. Blackwell, it is existential. If the cosmos can make a place forever receding, can will and engineering overcome geometry? His solution is theoretical, elegant, and, by the standards of established physics, audacious to the point of heresy. Using the configurator's quantum field manipulation capabilities, Dr. Blackwell theorizes that the ship can create a localized region of modified space-time around itself, a bubble in which the expansion rate is effectively neutralized. Think of it as negotiating with the fabric of space. Rather than outrunning expansion, you alter the immediate geometry so the local rules differ from the cosmic background. The ship does not outrun the expansion. Instead, it carries with it a negotiated pocket of space-time that is insulated from the universe's overall metric. Within that pocket, distances behave differently. The recession velocity of distant objects is recalculated relative to the bubble's frame. Dr. Blackwell has mapped the trajectory not just through space but through the evolving geometry of expanding space-time, accounting for the galaxy's recession velocity at every point along the journey. The recession velocity of galaxies is a fundamental concept in comprehending the expansion of the universe. It is defined as the velocity at which a galaxy is receding from Earth, directly proportional to its distance. This relationship is articulated through Hubble's law, which posits that the recessional velocity of a galaxy is proportional to its distance from Earth. Mathematically, this can be expressed as nu equals h0d, where nu represents the recession velocity, d denotes the distance to the galaxy, and h0 signifies the Hubble constant. The math requires continuous adjustment, careful energy budgeting, and precise quantum coherence. Theoretically possible, practically perilous, a misalignment could leave the bubble tearing at its edges, exposing the vessel to exponential redshift and energetic feedback. Still, he refines the equations as if tuning an instrument, convinced that the right configuration will harmonize ship and space. Atom by atom, structure by structure, the configurator hums and pulses with light as matter is broken down and reborn in new configurations. The hull materializes like a thought becoming solid. Atoms arranged in lattices, orders that trade lightness for absolute tensile integrity. The propulsion chambers crystallize into existence with a precision no human hand could achieve, every grain oriented to channel stresses and quantum fields. The vessel grows in the space of the launch facility, not assembled, but conjured. Its internal architecture is as much a geometry of fields as of materials. Nested resonant cavities, superconducting conduits, and field generators integrated seamlessly at the atomic scale. Its hull is configured for maximum resilience against the radiation and particle bombardment of deep intergalactic space. Layers of bespoke alloys and metamaterials scatter and absorb micro-impacts and high-energy photons. Its propulsion system does not burn fuel in any conventional sense. It reconfigures the atomic structure of its own reaction mass in real time, extracting energy from controlled transmutations and quantum state changes. Reaction mass is transformed into directed momentum by manipulating binding energies and releasing them in precisely vectored pulses. It is, he thinks, the most beautiful thing he has ever made. A ship that feeds on matter and converts it directly into motion. Built for one journey, pointed at one destination, designed to be as autonomous and self-correcting as the math behind its creation. The launch is not loud. There is no roar of conventional engines, no pillar of fire. The ship rises on a column of reconfigured energy, silent, luminous, purposeful, like a new moon lifting itself from the ground. Technicians hold their breath, instruments recalibrate. Dr. Blackwell watches with a calm that is almost ceremonial. Ahead, the stars, and somewhere among them, stretched red by the distance of billions of light years, the faint smear of light that he has chosen as his destination. The journey will be long. The physics will resist him at every turn. Yet in that silence there is also an intimate clarity. This is where experiment becomes pilgrimage. The galaxy will continue to recede, and there will be moments, he knows this, when the mathematics will seem to say that the gap is growing rather than closing. Instruments report rising redshift, telemetry flickers, and the configurator's quantum field geometry must be retuned. The space-time bubble requires constant adjustment, the quantum field geometry shifting in response to the universe's expansion, the configurator working continuously to maintain the negotiated space between the ship and the relentless outward flow of everything. There are nights, subjective nights in the ship's cadence, when doubts press against him. Equations that had behaved obediently during construction throw unfamiliar terms into the mix. Energy reserves constrict. The bubble's seams shimmer. Each time, Dr. Blackwell responds with the same steady combination of calculation and craft. Slight reconfiguration of field parameters, subtle reordering of reaction mass microstructure, and minute course corrections that over weeks and months add up. But Dr. Blackwell has always been most himself in the presence of an unsolved problem. He delights in the incremental victories, a percent less redshift than predicted, a steadying of field coherence, the faint return of spectral lines once thought irrecoverable. And slowly, against every classical prediction, against the universe's own expansion, the gap begins to close. The red light grows, not quickly, not easily, but measurably, undeniably. The destination approaches. Dr. Michael E. Blackwell has a PhD. He has an invention that can rebuild matter from its foundations. He has a ship configured for the impossible, and he has something that no instrument can measure and no equation can fully capture. The absolute certainty that the red light on the horizon is not a boundary. It is a destination. It is home. He calls it the Red Home Horizon, a name that carries both the color of its light and the geometry of the hope behind it. Naming is an act of possession and of promise. It binds intention to place. As the crimson smear resolves into structure, as spectral features reassert themselves and the impossible becomes addressable, the name feels less like bravado and more like prophecy. He is on his way, and whatever waits within that red glow will be met by the careful hands and unflinching mind that built the path to it. It is he, Dr. Michael E. Blackwell.